Welcome back to I Can Science That. If you've been following along with our solstice observations, about a week ago we got together, we gathered the community, and we went out and did an observation of where is the sun on the solstice at noon. People from all over the world contributed. Everybody just went out there and using very simple tools available to everyone, we went out to ask the question, where is the sun? Point at the sun. Hey, there's the sun right there. We go out at noon and we measure that angle. We used some tricks to simplify this process using just a stick and some shadows. Measured those, collected all of that data, and I've presented that data already here. I've made that data public. I've been overwhelmed by the response that we got to this. A lot of people really excited to get out there and find out for themselves the true data, to contribute and to observe for themselves, to participate. A lot of people have been really excited about that. I want to keep that going. Let me give a couple of shout outs. Michael Dam Olsen has put a second video out. We looked at his previous one before, but this one, he shows moving the sun up and down and what that means in terms of the flat earth prediction. So he made a little sim where he can move the sun up and down, and then it adjusts the angles to point at that sun. And you can compare those, they're shown in red here, against the green ones, which is the ones we actually measured, and try to somehow make sense of where the sun is in this model. So check that one out. I'll link it down in the description. Another contributor by the name of Ion has gone even further and created what I consider to be the absolute best visualizer of this data set, at least so far. This is an interactive simulation that you can try yourself. He's got north over there on the left and south on the right. But this is the same data that I was just showing. This is the actual data of where the sun appears to be. This is just, imagine yourself standing here and you point and you say, there's the sun. I see it. It's right there. This is the line you would be pointing along, at least according to our measurements. So one of the complaints that I get is that we've assumed something. We've assumed the sphere. We've assumed the sphere. And this graphic shows we very much are not assuming any spheres. Or how about we've assumed the distant sun? Well, this is not assuming anything. This is just showing the actual data. But let's show the interactive part. What can we do, as it's indicating there, if we just drag up and down? Here we go. As I drag up, I can pull that data into a spherical shape. And as I do, look what happens to the lines. This is just showing where those lines point based on the observations. Let's go back the other way. We can actually pull it into the opposite shape. So if there's any concave earthers out there, you can try adjusting, and we'll start with flat and make it a little concave. Where can we adjust? How can we adjust to get all those sun points to be pointing at the same thing? Ultimately, that's the concept and that's the question. Everyone during these observations is at noon. So at solar noon, that is, when the sun is at its highest point. And they point and they say, hey, there's the sun, there's the sun. We all point, and then we just follow the fingers to where everyone is pointing. That should be where the sun is. And as you can see, some of them are crossing here, some of them are crossing over here. They can't agree. So by using the simulation, you can adjust the shape of the Earth until you find a way that everyone's pointing at the same thing. So can it be concave? Does that help? No, that totally doesn't work. This person here is pointing into the ground there, and this person is pointing up at the sky over there. No, that's not going to work. That doesn't help. Try any angle you want. How about here? Like right here, I can get this observation to go like, how about this one? This one's going right through this kind of cluster, right? But then wait a minute, over here we got crossings over here, we got crossings up here. They can't agree. But if I do this, Now we see something else, which is that now everyone's pointing at the same spot. Everyone now is pointing at the same spot in the sky. That spot is very, very far away. It's way off the screen, in fact. But that's how we can resolve this. And so if you're saying to yourself, I have no idea. I have no idea whether the Earth is flat or the Earth is round. You can just look at this data set and say, well, what can I conclude from that? If we're all looking at the same sun, the only way that we can make that work is this. This makes that work. So it looks like the Earth must be curved in some kind of way. It's a convex shape, and it's roughly spherical. That's the only shape that really works. And I really love this demo, so I wanted to share that with you. I'll link that down in the description. So where do we go from here? Now that we did this and we had so much success with this, are we ready to move on to another observation? Should we maybe drill into this a little bit more? I'd like to say thank you to those flat earthers who've contributed so far to the conversation, at least those who've contributed in a constructive way. Rachie dropped by with her comments. Thank you for that. Maybe we could follow up on those a little bit, get some clarification on exactly what you'd like to say with this. I wasn't entirely clear about that, so looking forward to that. Glenn, of course, was in there, and I think Glenn's main point is something about refraction. I think that Glenn wants to talk about refraction, so that's certainly something we could investigate more deeply. And there was another contributor, Resistance, who wanted to talk about the parallel nature of the light and did not believe that the light could be parallel based on observations that we've had, particularly corpuscular rays. So maybe that's a direction we could take things next. So let's hear it from you guys. There are many topics we could discuss. Let's hear from you where you want to go next. Do you want to talk about refraction, the impact of water perhaps, or clouds on refraction, the straightness or parallelness of corpuscular rays are both interesting topics. Or if there's something else, like I believe Rachie maybe was alluding to the optical drop phenomenon perhaps, but I wasn't entirely clear about that. Maybe we could dig into that. Other requests that have come by, I've had a request to talk about whether 3 points on the surface of the Earth make a triangle, or do they, because the Earth is curved, maybe they do not. We could look into that a little bit. Or the phases of the moon. Does the moon's light really match the angle that it should if the sun is what's causing that? Or how about perspective? Perspective is very fundamental to a lot of this type of data. We could just go out there and take pictures of objects at different distances and see if the equations of perspective hold up or not. And one last experiment I want to try is to drop some objects and film them so that we can get timings of how they accelerate downward, harkening back to some discussions of a relative density and gravitational acceleration that were going on sometime last year. So you guys let me know. See you down in the comments. Let me know what you want to do, where you want to take this, and we'll go further. Thank you all for the contributions and for just being excited about doing science and sharing it with other people. Sharing these results and sharing this interactive display, really fantastic.